Okay, so this is the last part of atomic structure. So we're going to focus on ionization energy for this video. So the first ionization energy is the energy needed to remove 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of gaseous 1+ ions. So basically, you have an atom, you remove an electron from the atom, and now you have a gaseous 1+ ion. Okay, now notice how both the atom and the ion are in the gaseous state. That's really important. Okay, now instead of remembering this whole definition, I'd say just remember the equation. So you have an atom that is gaseous, and then you form gaseous +1 ions, and then you also form an electron, or you release an electron, and that's because you removed it from this atom. Okay, so you remove 1 mole of electrons like this from 1 mole of gaseous atoms like this to form 1 mole of gaseous 1+ ions right here. Okay, successive ionization energies. The nth ionization energy is the energy needed to remove 1 mole of electrons from 1 mole of gaseous n-1+ ions to form 1 mole of gaseous n+ ions. What you need to remember, if I write an equation as well for this one, so if I have the third ionization energy, I go from a +2 ion, let's just say M, 2+, to a M, 3+, and an electron. Okay, and we're in the gas state, always. So essentially, whatever ionization energy it is the charge you're forming. Okay, so since this is the third ionization energy, we're forming a +3. Okay? Now you also need to know the factors affecting ionization energy. There are 3 main factors. This includes the attraction of the nucleus. So the more protons in the nucleus, the greater the attraction. So if we draw the atom, for example here, and now we have our protons and our neutrons, and then we have our electrons in the shells. 1, 2, 3. Now I'm just going to draw a random atom. Okay, so if we want to remove this electron, okay, it's going to be harder for us if there are more protons here, because the positive charge of the protons and the negative charge of the electrons creates a strong electrostatic attraction. So the more protons there are, the harder it is to break that attraction. Okay. Also, the distance of the electrons from the nucleus. The bigger the atom, the further the outer electrons are from the nucleus, and the weaker the attraction is to the nucleus. So essentially, if this distance is big, the attraction will be weaker. So imagine if you have like 2 magnets. If you put the magnets close to each other, you'll feel a strong force, right? But if you put the magnets far away from each other, the force isn't really that big. So it's a similar thing here. If the distance is too big, the force will be weak. Shielding of the attraction of the nucleus. An electron in the outer shell is repelled by electrons in complete inner shells, weakening the attraction of the nucleus. So essentially what this means, so if we're removing this electron, right, these electrons in the inner shells here repel this electron, right, because they're both negative, and so if they're both negatives, they repel each other. So these inner electrons, they have an effect called shielding, which is just that repulsion force, okay, making it easier to remove this electron. So the more shielding there is, the weaker the force is, and the easier it is to remove that electron. A high ionization energy means there is a strong attraction between the electron and the nucleus, and so more energy is needed to remove the electron. Successive ionization energies. Within each shell, successive ionization energies increase. Okay, so basically what that means is this, so if I remove something from here compared to here, this one is harder to remove, okay? Now the reason is you're removing it from a more positive ion, okay? Because let's say I remove this ion, right? This electron. The ion is now +1, okay? If I remove it from here, I'm now removing, now it's become a +2, okay? If I'm removing this one now, it's become a +3, okay? So the more electrons I remove, the more positive the ion becomes. And that makes it harder to remove electrons, because since the ion is positive and the electrons are negative, there's a stronger attraction. So it gets harder to remove. Also, there's less repulsion amongst the remaining electrons, because there's less shielding, right? So since there's less inner electrons, okay, since there's less electrons in the inside, there's less shielding, okay? So that makes it harder to remove, and which means the ionization energy increases, okay? Because remember, the ionization energy is the energy needed to remove the electron, essentially. Okay. So what successive ionization basically just means is removing an electron after one after the other, and how much energy is needed to remove one after the other. So basically, as you remove one after the other, the energy increases. You need more energy to remove the second electron compared to the first. Okay, so that's basically shown in this diagram. So this is the amount of energy needed to remove the first electron. This is the amount of energy needed to remove the second, the third, the fourth, the fifth, and so on and so on. And it just keeps on increasing. Now, big jumps in ionization energy suggest to you that you are removing from a more inner shell. Okay? What that basically just means, if I draw this atom, alright, this isn't drawn to scale and I haven't drawn the nucleus very well, but it's good enough for the explanation. So, essentially, if I'm removing this electron, that represents this right here, this ionization energy. And then removing this electron represents this one. And then if I remove a third electron, that represents this one, right? Now, if I want to remove another electron, I'm moving inwards into a more inner shell. So I'm removing from more inner shell. Now here, there's less shielding, right? Because before, when I was removing from the third shell, there were two shells in between the nucleus and the third shell. So there was more shielding. Now, when I'm removing from this shell, here, the only bit of shielding is these electrons here. Okay, so there's less shielding. Also, the size of the atom, or the size between the electrons here and the nucleus is less, right? So the atomic radius is smaller. So the attraction is more stronger, right? Now, these factors increase the ionization energy by a bunch, okay? So here you can see there's a big jump, okay? This big jump shows that I've gone into a more inner shell for the reasons that I just explained, okay? Then I remove this one, 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 which is all shown by this, okay? Then I have two more electrons left, which I'm removing from a more inner shell. So once again, there's going to be a big jump. And then I can remove these two, okay? You may need to use this fact with the graph of an unknown element to work out what the element is, okay? So a lot of the times, they show you a graph like this and they tell you to figure out what atom it is. So this is done by checking how many jumps there are. So here, this is all. We can see that this is one shell because they're all relatively similar. This is another shell. and this is another shell, right? So this is 3 shells altogether. And then also, so since this is the most outer shell, we can look how many electrons there are, right? So there's 1, 2, 3 electrons in the outer shell. So we're looking at something with 3 shells and 3 outer electrons, right? Which means it's in group 3. So if you look at the periodic table, group 3, period 3, that means it's aluminium. Okay? Okay, so you also need to know the general trends of ionization energy. So as you go down a group, you're adding another shell. So that increases the atomic radius, or the size of the atom, and it also increases the shielding. Okay? Both these factors make the nuclear attraction weaker, which is the attraction between the electron and the nucleus, right? So if I'm just going to draw this. Okay, so this one here is in period 2, and this one here is in period 3, right? So we've gone down the group, and as we've gone down the group, we've added another shell. So because of this, there's more shielding, right? In this one on the left, there's only one shell in between the nucleus and the outer electron. Here, there's 2 shells in between, so there's more electrons repelling this outer electron. Okay, so for this one, it's removing this electron is easier than removing this electron. Okay, due to shielding. Another reason is because the atomic radius increases, right? So the size of this is bigger than the size of this. So this is a weaker force, or has a weaker attraction. Okay, so as we go across the period, so left to right, the ionization energy actually increases. Now this is because for the same factors. So you always need to link it back to proton number, or the number of protons, shielding, and the atomic radius. Now in both cases, the shielding is the same, right? Because there's only one shell between the nucleus and the outer electron, right? But the nuclear charge is different, right? So here we have 3 protons, and here we have 4 protons. Okay? Now, the reason why this has such a huge impact is that these protons actually pull these outer electrons closer. So the more protons you have, the smaller this distance is, because these electrons are being pulled in closer. Okay, so this is a smaller distance, and then also this attraction is going to be stronger. Okay, because there's a more positive nuclear charge. So with this smaller distance and greater nuclear charge, there's going to be a stronger attraction, so a higher ionization energy. Okay, so the general trend across the period is that the ionization energy increases due to these reasons. By the way, for your exam, I wouldn't really use the word distance, I'd use the word radius. Okay, that's just what exam boards prefer. And I'd say smaller atomic radius. Okay, so we've just said that the general trend across the period is that the ionization energy increases. However, there are a few anomalies, okay, as you can see from the graph, okay, where the ionization energy actually decreases. Okay, now the reason for this first one, from magnesium to aluminium, is that as you go from a group 2 to group 3, you're removing you're removing an electron from a p orbital instead of an s orbital, meaning you're removing from a more outer electron, so you need less energy. So for magnesium, the electron configuration is 1s2, 2s2, 2p6, and 3s2. For aluminium, the electron configuration is 1s2, 2s2, 2p6, 3s2, and a 3p1. Right? I'm just going to make this clearer. Okay. Now, if I was to draw this last bit, right? So, for magnesium, the 3s2 is here, right? And this is the most outer electron. However, for 3p, you're removing from here. And this is a higher energy level. Okay? So, if you think of your structure of the atom, it's more outer, okay? It's further away from the nucleus. And because of this, you need less energy to remove it. So this one here, you need less energy to remove. Okay, and that's why the ionization energy decreases for aluminium. Okay, a 3p1 is easier to remove than a 3s2. Okay. Now for our second anomaly over here, the reason is for the decrease is that as we go from group 5 to group 6, you have two electrons in the same orbital which repel each other, which means it is easier to remove the outer electron when compared to group 5, which doesn't have two electrons in the same orbital. So if I write down the electron configuration for phosphorus, I'm just going to write down the shorthand configuration. So it is neon, 3s2, 3p3. So this is phosphorus. And then sulfur is neon, 3s2, 3p4. Okay. Now if I just draw this, the 3p's, right? So for phosphorus, this is what it looks like. And for sulfur, this is what it looks like. Now, in sulfur, this extra electron here is easier to remove because there's a repulsion in this orbital, since these two electrons are really close to each other. So this electron is easier to remove, and that's why the ionization energy decreases. You need less energy to remove this one. Okay? That's atomic structure done. If you guys enjoyed the playlist, make sure to like and subscribe and comment down below what topics you guys want me to go through next.